Okay. Now I told you last week we did prediction reactions where I gave you the reactants in formula form. But I told you that's the easy way. Okay? It's much easier if I give you the formulas for the reactants. More likely, you're going to get reactions written this way, where I give you the names. There's that additional skill set required here that says, Mr. Cordero, I know how to convert a name to a formula and go from there. Now, what are the challenges that are different with this type of question than the other type? The challenge is, do you remember the little things? Okay? Do you remember you swap and drop ionic compounds? Okay? Do you remember that you got to look for special elements? Right? Because if we forget those things, then we're not going to get the balancing right, or we may not get the products right at all. Okay? So it's really important that those basic skills we learned at the beginning are still present. All right, so let's have a look at number 1 here together. So I've got lithium nitride. Okay? What kind of compound is lithium nitride? Ionic. Okay? Lithium's a metal. Nitrogen is a nonmetal. Okay. So I've got lithium and I've got nitrogen. We said it's ionic, so I write the charges. Nitrogen's a -3. Lithium's a +1. What do I do with them? Drop and swap. Okay. All right, so my first compound is good, and it reacts with water. 2 ways to write water. Which way would be the most logical way, given that I have an ionic compound here? HOH, yeah, okay? Because then we're looking at most likely a double replacement reaction, right? Okay, so if we write it in kind of the ionic way, it'll be easier to trace. Now, that said, were you to write the reaction as Li3 reacts with hydrogen, or sorry, reacts with water, and you wrote it this way, you would get different products. And if you did it that way, technically, either way would be correct. All right, so I'll go over both, but I couldn't mark you wrong if you followed the steps on how to predict. Because in reality, both happen, okay, when you mix these two things together. All right, double replacement reaction, what do I do to predict the products? Jared. Switch the metals. All right, what's acting as a metal here? Hydrogen. All right, so hydrogen is going to end up with nitrogen. Lithium is going to end up with hydroxide. Okay, what do I have to do with those two compounds? Drop and swap. They're both ionic. Okay, so -1, +1. All right, do I have to do anything with that? Okay, should I put brackets on that one? No, because I don't need to write a number beside OH. I don't need to write brackets either. Okay, and then for this one, I've got -3 and +1, so we got H3N there. Okay, if I wrote it this way, okay, how would my products be different? I'm still going to swap the metals. But instead of lithium ending up with hydroxide, lithium's going to end up with oxygen. Okay, and that's okay. Okay, so we got a drop and swap here, drop and swap this one, so that'll be Li2O. The balancing is a little trickier for the bottom one than it is for the top one. Okay. All right. So let's do the balancing for the top one here. Okay, I've got 3 hydrogen over there, but I've only got 1 over here. So what should I put here? 3. Okay, that gives me 3 hydroxides, so I got to put a 3 there. Does that make my lithium work? Yeah, and I've got 1 nitrogen on both sides. Okay. Now, for this one, I've got 3 lithium over here and 2 over there. Okay, is that going to give me a bit of a problem? Okay, what's the lowest common multiple? 6. All right, so if I put a 2 here, okay, and a 3 here, that takes care of that. That gives me 3 oxygens. So if I go over here and put a 3 there, how many hydrogens does that give me? 6. Okay, so if I put a 2 here, that makes my hydrogen work. Do my nitrogen work? Yes, they do. Okay, everybody all right with that? So you can see, it takes a little bit longer to do the ones that are written out in words, and there's a few other little things to watch for. Okay. Okay, this would be one of them. In this question, I actually wrote that sulfur was S8, but I guarantee you on a test I would not. Okay, I would simply say that powdered zinc reacts with sulfur, and expect that you would check your periodic table, okay, before proceeding to predicting the products. All right, because if you didn't, you would go, and you would probably predict the products, right? You'd go, okay, it's a synthesis reaction, so -2, +2, good. And, oh, sweet, I'm done. Except, you're wrong. Okay? Because you've said that the balancing is 1, 1, 1, when in fact, the balancing is 8, 1, 8. Okay? So a little mistake like that costs us. All right? Those are the little things that we want to watch for. Okay, I want you guys to try, okay, write down 3 through 6 here and give them a try, okay, and then I'm going to go through them in a few minutes. Okay, little tip. Once in a while, a question gives you a piece of extraneous information. Extraneous means interesting but not required. The fact that bauxite ore exists is, yeah, completely irrelevant to that question. All you need to know is that it has this stuff in it, aluminum oxide, and that's going to decompose using electricity. Okay? You don't need to worry about trying to find what bauxite is. Okay? It's a rock that contains aluminum. Okay? That's where we get aluminum from, is from bauxite ore. All right. Okay, let's have a look at number 3 here. Okay, so I've got aluminum oxide. Okay, which is an ionic compound, so it's got to be dropped and swapped. This is a -2, so the 2 goes there. This is a +3, so we got Al2O3. Decomposes into its 2 elements, aluminum and oxygen. Now, what do I have to look for? Special elements. Aluminum's a metal, so it's not special, but oxygen is special, right? It's a non-metal and it comes as a 2. Now, what do I have to do? I got to balance. Okay. I've got 3 oxygens on one side, I've got 2 on the other. Lowest common multiple is 6. All right, so 2 times 3 is 6, will give me 6 there. 3 here gives me 6 over there. But how many aluminums do I have? 4. Right over here, put a 4 there, and we're good. Okay. So the little tricks, guys, are always watch for special elements. If there is one thing that costs people marks, it is missing or forgetting the special elements. So anytime you have an element by itself, don't be cocky. Double check your periodic table to make sure it is or is not special. Okay? Because that's the mistake I see most often on unit exam, on the assignment you're going to do tomorrow, is people just being too arrogant to look, okay, and see if that's special or not. All right, give you a couple more minutes here. Okay, let's have a look at number 4 here. So we got propane burns in oxygen. So C3H8 plus O2. What kind of reaction is that? Combustion. Products are always CO2 and water. Okay. Do I need to apply the rule of 2 for this one? No, 3 is an odd number. Okay, so balance alphabetically. 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens. 3 times 2 is 6 oxygens, plus 4 more oxygens is 10. 5 times 2 is 10. Okay, I think we've done that reaction now about 10 times. Okay. All right, how many people have done number 5? Okay, let's have a look at that one then too. Okay, does it matter in this question that sodium chloride is in solution? It makes no difference whatsoever. Again, it's an extraneous piece of information. And the reason I put that stuff in there is because we try and put more and more extraneous stuff into questions so that you guys really begin to read questions well. By the time you get to grade 12 and you're doing 30 level sciences, there's so much reading that starts a question off. Like last year, physics diploma exam, there was one point where there were 2 questions that had to be answered, and the preamble to them was, read the following pages. Pages. It was a page and like 3/4 of stuff about this experiment to do with cathode ray tubes. Okay, it was a page and a half about it, and then you used that information to answer 2 questions, and only one of them actually required any calculating. Okay, it was ridiculous, but you have to be able to sift through lots of information to get the stuff you need. So that's why we're kind of starting that skill now. Okay, all right. So in solution seems a lot better than page and a half, page and 3/4 of reading. All right, sodium chloride, NaCl, okay, reacts with lead 2 nitrate. Okay, Pb 2 plus nitrate. Okay, that's a -1. So, gonna need brackets around that one. Wow, I made that way too big. I'm gonna run out of room here. Okay, what kind of reaction is that? Double replacement, yeah. Okay, we got 2 ionic compounds. So we switch the metals. Sodium is going to end up with nitrate. Lead's going to end up with chlorine. Okay, what do I have to do with both of those compounds? Drop and swap. Okay, these are both 1s, so they're okay. Okay, what's the charge on lead? 2, because that's what it was over here. Doesn't change in a reaction. Okay, so this is 2 plus, this is 1 minus, so we got PbCl2. All right, now what do I do? Balance the reaction. All right, there's 2 nitrates over here. There's only 1 over there. So I'm going to put a 2 there, which gives me 2 sodiums. So I back up and put a 2 here, which gives me 2 chlorines. There's 2 chlorines over there. So it looks like we are 2, 1, 2, 1. Okay. Everybody all right with that one? Okay. Give you a few more minutes here on 6. Okay, so let's have a look at number 6 here. So I've got aluminum that reacts in a single replacement reaction with sulfuric acid. Again, something I would not give you right on a unit exam. I would not tell you the reaction type because that's pretty much a giveaway. Okay, so aluminum reacts with hydrogen sulfide. I also would not use the word sulfuric acid. I would use hydrogen sulfide, okay, because we didn't go over the acid naming stuff. Okay, so okay, we got a single replacement reaction. What's the metal in hydrogen sulfide? Hydrogen. Okay, it's listed first, so it's acting as a metal. So we swap them. That means hydrogen ends up by itself, and aluminum ends up with sulfur. This is a -2. This is a +3. So we got Al2S3 for aluminum sulfide. Anything else I need to do? Right. Hydrogen is special. I got to check for special elements. All right. Now, I got to balance everything. Well, I got sulfur present in the highest number. I'm going to balance it first. There's 3 over there. Now there's 3 over here. How many hydrogens does that give me now? 6. Okay, so 3 there. I got 6. How many aluminum do I have? Okay, is that making sense? Ringing a bell for everybody? How many people are done the 2 worksheets you got from my sub on Thursday? Okay, that's kind of what I thought. All right. I want to spend today finishing those up and answering questions that you may have on those. All right, tomorrow you'll have class time to do the assignment, okay, which of course you'll get less help from me on because that one's coming in for marks and I want to know how well you can do it, not how well you can do what I tell you. Okay. Actually, no, I do want to know how well you can do what I tell you, but not that day, what I told you before. Okay. Oh, yes, absolutely. Yeah, you can use your notes for the assignment. It's not a test, it's just I want to see what you can do. All right? So that is the plan. Ask questions today, guys. If there's something that confuses you, ask. The keys for those are on the website. Okay? If you go onto my web page there, and under Science 10 stuff, where all of your stuff is, in the chemistry folder, there's a file called Keys to All Reaction Worksheets. I think you've used it already once. Okay? Keys to All Reaction Worksheets. You just got to scroll through it, but the keys for the ones you're working on are on there as well. Okay? Do a few, check. Do a few more, check. Okay? Okay, question is 6 and 7 on this sheet. You probably wouldn't get one like that on a unit exam. You might get it on the assignments, okay, but probably not on a unit exam. This is one of those ones like what we did in the lab, where we have to kind of trace where everything goes. Okay, so for number 6, okay, I've got ammonium chloride on this side, but I can see that I don't have ammonium on the other side, which means it's split up. Agreed? Okay, so part of it became this, but one of the hydrogens probably ended up where? Yeah, probably over here. Right? So there's the other hydrogen. It's accounted for. I've got 4 hydrogens on this side. I've got 4 hydrogens on this side. Okay? My problem is my hydroxides. I've got 2 over here, but only 1 there. So if I put a 2 there, that suddenly throws off my hydrogens over here. Agreed? Okay. So looking at that, we can start thinking maybe if I put a 2 here, okay, now that gives me 8 hydrogens over there. So if I put a 2 here, does that give me 8 hydrogens on this side? It does. Okay, so now my hydrogens are balanced. So we're kind of going one thing at a time. Okay, how many chlorine does that give me? 2. And there's 2 over here. It's looking good so far. 1 calcium over here. 1 calcium over here. Yeah, I think we're done. All right. The next one down works pretty much the same way. Okay, just got to kind of trace where they go. Again, it's ammonium breaking up and going into 2 places. Okay, so it's not a lot different than number 6 is. They're just to challenge you. All right. See, if you're getting cocky about how good you are at balancing, those will humble you a little. Unless you're that good, and then, well, it's hard to be humble then. It sounds like a song, right? Yeah. I won't. Okay, good question just came up. Okay, Jamie tells me that the sub addressed this, but I totally forgot to ever address it with you guys. Once in a while, a question, like in this case, this is just a mistake. On question 11 here is simply a mistake. There should have been a Roman numeral in this compound. But once in a while, you'll get a question where, let's say it was a single replacement reaction, but it was copper sulfide reacts with chromium. Okay, so in this case, it's also a good example because copper is also a multivalent metal. Right? So if I've got chromium sulfide and it doesn't tell me which chromium, which one do I pick? Right. The first charge listed is the most common charge. Okay, so you always go with that one if there's no other way to find out. First off, this is a mistake. This should have said chromium 2 sulfide in it because it was supposed to have a Roman numeral, just doesn't have one. Okay, but copper metal is also a multivalent metal, and because it started out as an element with no charge, there's no way for me to know which charge it had going forward into the products where chromium, will be by itself and copper will be with sulfur. Okay? There's no way for me to know on copper which charge it has. So that's why they're listed in order of their occurrence. Most common charge for copper is 2. Okay? So in that case I would go, okay, this is a -2, this is a +2. I don't have to do any balancing for that question because it's already done. Okay? That kind of thing. So does that make sense to everybody? Okay, so if that happens, and it's going to be in a single replacement reaction where it's going to happen, okay, that's basically the only type where it could happen. Well, I suppose maybe a synthesis reaction it could also happen too. Okay, you go with the most common charge. Any other ones coming up that are giving trouble, Leah?